Today, we are going to learn balancing word equations, and this isn't really anything different. What this is taking what you learned in naming and applying it to balancing equations, because a lot of times you're not given necessarily the compound formulas and you have to come up with them themselves. So number 1 states that nitric acid is added to barium chloride. Now, when it comes to these kind of problems, you're going to have the same ions on each side of the reaction. That's because whatever goes into the reaction on the left-hand side has to come out of the reaction on the right-hand side as a product. So our first one is nitric acid. The word acid tells me that my cation is H+. You always want to be doing your ions when you're talking about getting formulas from names. Pretty soon you'll be good enough at this where you won't have to, but for now, we want to use our ions for ionic compounds and acids. So we know we're looking for a polyatomic ion because it does not start with hydro. Ends in IC acid, so you know my polyatomic ion used to be nitrate, so it's going to be NO3. So IC acid means that the original ending was ATE, so we're looking for nitrate. These go together 1 to 1, so my formula is HNO3. The charge on nitrate tells me how many hydrogens I need. Next, let's go to barium chloride. Barium is an alkaline earth metal, so its charge is +2. Chloride is a halogen right next to the noble gases. He only needs to grab 1 electron to be a happy compound ion. So now I'm going to put these together. Barium has a charge of +2, chlorine is -1. So you can either give chlorine 1 to barium and barium's 2 to chlorine, or you can think about the fact that in order for there to be a neutral compound, you have to have 2 chlorines to balance out barium's +2. Now on the product side, it says hydrochloric acid and barium nitrate. We're still using the same ions. So these compounds are still going to have H+, NO3-, Ba+, and Cl-. This time, H+ is not going to be with nitrate. It's going to be with chloride. They're going to switch partners. This is called a double displacement reaction. So hydrogen going with H+ going with chloride goes together 1 to 1 also. And then barium going with nitrate, we're going to need, again, 2 nitrates. We're going to practice some more balancing by inspection, where I'm going to say, okay, I'm going to pick the most complicated, which is barium nitrate, and I'm going to balance nitrate by doing this. And then I'll turn around and balance hydrogen by doing this. And I'm all balanced. That's the answer to number 1. Number 2 states that zinc plus carbonic acid zinc is a metal. When you put metals into acids, they will react. And I get zinc carbonate and hydrogen gas. So let's get what we're dealing with here. When we say zinc, it's just Zn. When they're in the elemental state, they have no charge. Only ions have charge. When it's an element standing by itself, it is neutral, has a charge of 0 because it has 30 protons and 30 electrons. Let's go to carbonic acid. Acid tells me it's H+. There's no hydro, so I know I'm looking for a polyatomic ion. And because it ends in IC acid, the polyatomic ion I'm looking for is carbonate. The -2 on carbonate tells me I need 2 hydrogens, so it's going to be H2CO3. Now, on the other side, what's happened is carbonic acid is going to take 2 electrons away from zinc, and zinc's going to be a +2. Now that zinc is with carbonate, which is a -2, they go together 1 to 1. And next is hydrogen. What do I write down for hydrogen? What's the formula for hydrogen? Georgia? H, you think?
H2.
Remember our diatomic elements, right? Let's review real quick our diatomic elements. Those are our high 7 elements. High for hydrogen, and then go to number 7, and let's make a 7 over on the right-hand side. So number 7 is nitrogen. Nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, along with hydrogen, are our 7 diatomic elements. That means hydrogen's H2, nitrogen's N2, oxygen's O2, fluorine's F2, chlorine is Cl2, bromine is I2, and iodine is bromine is Br2, and iodine is I2. Now this will happen occasionally. If you notice, I have 1 zinc on the reactant, 1 zinc on the product, 2 hydrogen on the reactant, 2 hydrogen on the product, 1 carbonate on the reactants, 1 carbonate on the products. This is balanced. So you don't necessarily need to have any coefficients. Sometimes it's already balanced. Number 3 is aluminum hydroxide. Is added to ferrous chloride. They will swap partners, and I will get aluminum chloride and iron 2 hydroxide. So these are all ionic compounds. Let's put our ions on top. Aluminum is the one we mistake most often, but it is in your list of single elements. You'll see aluminum is in family 3, has 3 valence electrons. It will have a charge of 3+. Hydroxide is a polyatomic ion that you can look up. By now, you probably remember hydroxide because we've used it so many times. Ferrous is iron 2+, and chloride we already went over. So let's put these reactants together. You can either say to yourself, I need 3 -1s to balance out my +3, or you can give hydroxide aluminum's 3 and give aluminum hydroxide's 1. So it's AlOH3. Same thing with ferrous chloride is FeCl2. Now aluminum's going to be with chloride. So it's AlCl3. And iron 2 is going to be with hydroxide. So they switched partners again. Let's go to aluminum hydroxide to start balancing. I'm going to balance by inspection in this particular lesson. we have 3 hydroxides in the reactants, 2 hydroxides in the products. Who remembers, what am I supposed to do when I have 3 and 2? Yes. Double the odds. So let's put a 2 here. And you're going to notice the rest of them really seem to fall in place. So this is my balanced equation for number 3. Let's go on to number 4. Sodium hydroxide is added to sulfuric acid. And I get sodium sulfate and water. Sodium hydroxide is a strong base. It is the main ingredient in drain cleaner. So Drano's main ingredient is sodium hydroxide. That's why it gets rid of drains, because it eats through stuff. What do you think clogs in your drain are usually made of? What's clogging up your sinks at home? Hair? Usually hair and fat, like grease or any other kind of food. So this eats right through it. Unfortunately, it's not too kind to our pipes either, so it's really a bad idea to use Drano. Any plumber will tell you that. It's also a bad idea to put it in our groundwater system. This is the water that we're going to turn around and recycle. Then you got sulfuric acid. That's also a strong acid, meaning that if you poured it on your skin, it would burn really bad. Acid burns are particularly nasty. This one is a particularly nasty acid. So you got to be super careful with sulfuric acid. But you add this strong base and the strong acid together, you get sodium sulfate, which is a salt, and water. So you get salt water when you add them together. This is called an acid-base neutralization reaction. So let's get our ions going. Sodium hydroxide is one of those compounds we're going to be using all over the place. So you probably already recognize the formula for sodium hydroxide. We've used it so much. Sulfuric acid. Acid means that its cation is H+, and then the polyatomic ion I'm looking for is sulfate. We want to use our ions because that reminds us that it's not HSO4, it is H2SO4. And then on a product side, we have the same ions going out the other side. Remember, law of conservation of matter. The reactants have to have the same number and kind of atoms as the products. So these two compounds are going to switch partners. Sodium's not going to be with hydroxide anymore. It's going to be with sulfate. And H is going to find OH like it loves to do. So Na2SO4 and then HOH, which is just another way to write water. Sometimes this is helpful when it comes to the polyatomic ion OH. I'm going to put a 2 here, which means I have 2 sodiums and 2 OHs. Let's go put it here. So we have 2 OHs, and that matches up with the fact that I have 2 H's here and 2 OHs here. Will match up with my 2 H's here and my 2 OHs there. So if that makes it easier for you with a double displacement acid-base neutralization reaction to balance, that is one strategy that might help.